Hello everyone, welcome to our presentation. My name is Yingjun. Today I will give a presentation of our CVPR paper, SuperDisco, Superclass Discovery Improve Visual Recognition for the long tail. In this paper, we mainly focus on the long tail problem. We first propose a SuperDisco to learn to discover the superclass graph for long-tailed visual recognition. And we construct a learnable graph that discovers the superclass in a hierarchy of semantic abstraction to get feature representation learning. And we also using the meta learning to propose the meta SuperDisco to get a more process graph for the long tail problem. So in the long tail problem, the head class feature space learned on this sample is often larger than tail classes, while the decision boundary is usually biased towards the dominant classes. And from our experiments, we also visualized the long tail features, and we found that head data dominated the distribution of classes, which caused the tail features to fill within the head feature space. But in the real world, each category has a corresponding superclasses. For example, bus, taxi, and train all belong to vehicle superclass, right? So this observation raises the question: are superclasses of categories also distributed along a long tail? Based on this question, we first plot the distribution of original classes and superclasses in different imbalance ratios, and we found that the data imbalance of superclasses is considerably lower than those of the original classes. And from the figure B, we found that the distribution of superclasses is almost a balanced space, right? So based on this observation, we first propose a SuperDisco to learn to discover the superclass graph for long-tailed visual recognition. And we construct a learnable graph that discovers the superclass in a hierarchy of semantic abstraction to get feature representation learning. These balanced superclass features could be used to get the original tail data away from the dominant row of the head data, thus making the tail data more discriminative. Here is the overall framework of our SuperDisco. And the first row is the original feature. And we first input the original feature to the first level superclass graph, C1. And then we can get the refined feature C1. And from the superclass graph C1, we can categorize the train and bus and the same superclass. And then we input the refined feature C1 to another level superclass graph C2, and we then get another refined feature C2, which is more balanced space. And the right figure is show the visualization of the discovered superclass graph. And from the figure B, we can see that the boy and the girl will categorize the same superclass H2. And from the C, from the figure B, we found that the snake, lizard, and the pan, oak belongs to the same superclass H3, but with the next level C2, we found that the snake and the lizard belongs to the same superclass, but the pan oak belongs to another superclass H1. So with another level, with a higher level superclass graph, we can get a more balanced superclass. So first is the SuperDisco. We first need to define superclass graph C L. Here L is a different level superclass. And for this graph, we have the vertex HC and its corresponding edge. And then we combine the original feature and the superclass graph. We use the message passing to get the refined features. And with message passing, the original features are rectified and refined, which attend to the most relevant entities according to the similarity between the original image space and the superclasses. And we also propose a meta-learning variant of SuperDisco to discover the superclass graph, enabling the model to achieve more balanced image representations. And in this scenario, we have a small amount of balanced data and validation data. And then we use this balanced data to construct a prototype graph, P. And then combine this prototype graph and the superclass graph, we can get another supergraph S. And then we also use the message passing to get the refined features. And first, from experiments, we first show the benefit of SuperDisco and SuperMeta SuperDisco. And we found that SuperDisco achieves better performance compared to baseline, which is not using the superclass graph. And the Meta SuperDisco is even better for the long tail challenges. And we also give the effect of a number of superclass levels. Here, the different number indicates the different level superclasses. And we found that SuperDisco provides higher performance gains with more complex hierarchies. And we also give the visualization of SuperDisco, and our SuperDisco discovers superclasses hidden in each category, while Meta SuperDisco discovers more accurate superclasses. And we also show the visualization of refined feature, and our SuperDisco guided the original feature on being clustered into the corresponding superclass space and different levels, while the Meta SuperDisco obtains the more discriminative intra-class features. And here is the comparison with the state of the art on the long tail dataset, and our Meta SuperDisco also achieves the state of the art performance compared to the previous methods. But for our paper, we also have some limitations because we use the graph learning, so it will increase the inference time, but SuperDisco has little impact on performance of balanced datasets at the expense of increased inference time. In conclusion, in this paper, we first made an important observation. The imbalance factor of superclass is considerably lower than the imbalance factor of original classes. So we propose a superclass graph to refine the original features. And then we use meta-learning to propose a meta SuperDisco, and the state of the art performance on 4 long tail datasets. That's it. Thank you.